Okay, so welcome to this class. So by now, I'm sure most of you guys have started solving questions from tutorial sheet 1, right? Okay, so if you haven't started, please start, okay? Because this is just tutorial sheet 1. There will be tutorial sheet 2, 3, 4, all the way up to tutorial sheet 8. So you better start working if you haven't yet started solving these questions. Okay, so we actually solved all these questions in this tutorial sheet, and you can access the videos on our website. And then for those who have an Android phone, you can even access the videos on a mobile app. Okay, so on the mobile app, you can download the videos and you can even watch them offline. Okay, so from this tutorial sheet for today's lesson, I'm going to pick questions on quadratic inequalities. Okay, so we will be looking at question 5 in particular. Okay, so question 5 is on quadratic inequalities, where we're just finding the range or the possible values of k given certain conditions. Okay, so now for you to answer these questions on question 5, okay, you have to know what the discriminant is. Okay, in fact, you first have to know what a quadratic equation is. And then from the quadratic equation, we get the discriminant. Okay, so depending on the value of the discriminant, it's going to tell you the type or the nature of the roots of that quadratic equation. Okay, and then if you're able to tell that, then you'll be able to answer what? These questions here. Of course, you also have to know how to solve quadratic inequalities. So I'll show you a very simple method so that you don't get confused. Okay, so to start with, we are going to start with the general form of a quadratic equation. Okay, so generally, a quadratic equation should be in this form. Okay, ax squared plus bx plus c is equals to 0. Okay, so this is the general form of a quadratic equation. So where there's a here, you can put any number that you want. Where there's b, you can put any number that you want. Even where there's c there, you can also put any number that you like. Okay, so from this general form of a quadratic equation, we can get what we call as the discriminant. Okay, so the discriminant is equals to b squared minus 4ac. Okay, so you can see that we get this b from the quadratic equation, the a from the quadratic equation, the c from the quadratic equation. So this thing here that I've written down is what we call as the discriminant. Okay, so this discriminant, it's very important in determining the nature of a quadratic, the nature of the roots of a quadratic equation. So now what do we mean by roots of a quadratic equation? Okay, anyone who can help us, what do you understand when we say roots of a quadratic equation? Anyone who can try? What do we mean when you say roots of a quadratic equation? Anyone? Okay, so roots of a quadratic equation, then we are just basically saying the answers to the quadratic equation. That's what roots of a quadratic equation is, okay? So let's say, for example, maybe you have x squared, okay? And then we say minus 5x, and then we say minus 6 is equals to 0, okay? Let's say we are given this quadratic equation, okay? And then we want to solve it. So let this be a plus. Okay, so when we solve this quadratic equation, we're going to say product factor and of course the sum, right? So the product here is 1, the coefficient of x squared multiplied by the constant. So my product is 6. And then the factors here will just be minus 2 and minus 3. Okay, and then the sum is minus 5. So when I add these factors, I get minus 5. When I multiply them, I get 6. So these are my factors here. So I can represent this minus 5x in terms of the factors. So it will be x squared minus 2x minus 3x plus 6 is actually equals to 0. And then we solve this quadratic equation. Okay, we are going to get what is common here is x, and then I remain with x minus 2. What is common here is minus 3, and then I remain with x minus 2 is equals to 0. Okay, so meaning I have x minus 2, and then our x minus what? 3 is equals to 0. So now when I solve this quadratic equation, we said you can equate this to 0. You solve for x, you're going to get x is equals to 2. We solve this, okay, we equate it to 0, we're going to get x is equals to 3. So these things here that I'm getting, the answers to the quadratic equation, they are what we call as roots of a quadratic equation, okay? Some people, they call them as the zeros of a quadratic equation, okay? So these roots, you can tell what type they are, even without solving this quadratic equation here, okay? So how can you tell the type of roots that you're going to have, or the type of answers that you're going to have for the quadratic equation? You look at the value of the what? The discriminant. Okay, so there are three possible cases that you can encounter. One, it may be that the roots that you have are two different real numbers. Okay, or two, it may be that the roots that you have here is just one equal rational number, or the roots that you have are actually complex numbers or are not real numbers. So those are the three situations. So those situations are based on the value of the what? The discriminant. Okay. So now let's discuss those three situations. Okay, so I'm going to say discriminant is equals to b squared minus 4ac. And then this is the general form of a quadratic equation. Okay, so situation number one is when the d, okay, the discriminant is greater than 0. Okay, so when the discriminant is greater than 0, we say that this quadratic equation has two, okay, real roots. Okay, and these two real roots should be unequal. Okay, unequal, meaning one can be 2, the other one can be 3, like the way we found there. Okay, so this is when the discriminant is greater than what? 0. And then when the discriminant is equal to 0, okay, when the discriminant is equals to 0, we are going to say this quadratic equation here, okay, has 1, okay, or we can say 2 equal roots. It has 2 equal real roots, okay. And then the other situation is when this discriminant is actually less than 0. Okay, so when the discriminant is less than 0, then we say that this quadratic equation has no real roots. Okay, it has no real roots, or we say it has complex roots. Okay, complex roots. So at your level, I don't think it might be there, okay, but it's rare to have a quadratic equation that has complex roots, okay, at your level, but it can be there. Okay, so these are the three situations that we have. Okay, so if we understand this, then we can solve all these questions that you can see here. Okay, we can solve all these questions that you can see here. So if it's greater, we said 2 real roots, equal to 0, 2 equal roots. Okay, if the discriminant is less than 0, we say the quadratic equation has what? No real roots. Okay, so we can use this to determine the nature of a quadratic equation, even without solving it. Okay, we can know the nature. So this is important for solving this equation. Another thing, okay, that is important for us to solve this equation is the issue of inequalities. Okay, so the inequalities are these things: less than, or you can have less than or equal to, and then you can have greater than, or you can have greater than or equal to. Okay, these are the inequalities that we are talking about. Okay, so there are sometimes situations where we are asked to find the range of values of x in a quadratic equation, or in a quadratic inequality, sorry. So meaning ax squared plus bx squared will be, we can get any inequality that we can choose from here. Okay, so let me leave this one the way it is. And then here I'll put ax squared plus bx plus c. Okay, we're going to put less than 0. Or we can have ax squared plus bx plus c less than or equal to 0. Okay, and then this side we're going to have ax squared plus bx plus c greater than 0, or we can have ax squared plus bx plus c greater than or equal to what? To 0. So these are the four types of inequalities that we can have that have a quadratic equation in them. Okay, so now how do we solve quadratic inequalities? Okay, so it all depends on the type of inequality that you have. So if you have less than or equal to, it means you deal with them in the same way. Okay, if you have greater than or equal to, you also deal with this in the same way. Okay, so we know that when you solve this quadratic equation or this quadratic equation, okay, so the first step when you want to solve these inequalities is to ignore the sign that you've been given there. Okay, just ignore the sign and then put it as an equal sign. Okay, put it as an equal sign and then solve this quadratic equation in the normal way that you would solve a quadratic equation. Okay, so we know once we solve this quadratic equation, okay, we may find that x is equals to maybe k, uh, x is equals to maybe k here, okay, and then we say, oh, x is equals to what? Let's say p. Okay, so of these two roots that you found here, or of these two answers that you found, one of them is going to be greater than the other, right? Okay, and then one of them is going to be smaller than the other. So if you are dealing with a less than or equal to, your answers should always be represented in this form. Okay, so let me create some space here. Okay, so once you've solved this, we said we have found x is equals to k and x is equals to what? To p. So let's say this p is the bigger number of the two roots that we've found. And then this k here is the smaller number of the two roots that we found. So our final answer should be represented in this form. If you are the less than, your final answer you just put x in the middle and then you say less than, and then here x should be greater than. Okay, so you put the smaller number here and then you put the bigger number here. This is how your answer should be represented always, as long as you have a what there, a less than. Okay, so you just solve the quadratic equation normally, and then you put the smaller number there and then the bigger number there if you have a less than. If you have a less than or equal to, it's the same thing, so you just put less than or equal to there. So it means the solution set when you have a less than or equal to should always be looking like this. So when you sketch this on the number line, I'll sketch it on top here. It will be that I have some number k here and some number p there, okay? And then I'm considering all the numbers from k to p. So you shade this part here. Okay, so that's the first situation. And then if you have a greater than or equal to, okay? So the first step we said you ignore the inequality that is there. So you just write the general, okay, quadratic equation like that, and then you solve. Once you find your answers, okay, x is equals to k, or x is equals to p. Okay, so we said this p should be the bigger one of the two numbers that you're going to find. This one should be the smaller one, right? Okay, so if your inequality was greater than, then your answer should be x. Okay, your answer should be x should be less than the smaller of the two numbers that you have found here. So since here we're taking the smaller number as k, we're going to say x is smaller than k, and then we say or ax should be greater than the bigger number of the two that you found, which is this one. That is when we have what? Less than. If you have, we have greater than. So meaning that if you have greater than or equal to, you just put here the equal to like that. Okay. So these here are the rules when we are what? When we are solving quadratic inequalities. So it all depends on the sign that you have there. Okay. So when we put this on the number line, it means I can have k somewhere there and then p. Okay. X says less than or equal to k. This means I'll shade on k and then I'll go back like this. And then here it's saying x is greater than or equal to p. I shade here and then I go this side. So my solution is to be that one and this one. So this scenario here is for greater than or equal to. This scenario here is for less than or equal to. Okay, so I hope that is clear. So if you have any questions, please ask before we can start solving the questions. Any questions there? Okay, so if there are no
Can
questions, oh, okay, there's a question.
you kindly repeat the part where you say x equals to k is smaller or x equals to k is bigger? How do you determine that?
Sorry, I didn't get you. What are you saying? You're saying I repeat on which part?
I'm saying, how
Mm-hmm.
do you determine k is smaller and p is
Oh,
bigger?
yeah. Okay, okay. So in this case, we are just assuming. I said when you solve a quadratic equation, you are expected to find two numbers, right? So of the two numbers that you find, one will be smaller than the other, one will be bigger than the other. So here we are just taking it for granted that k is smaller, okay? Because I'm just representing a general number, let's say k. I'm not specifying a number here. No wonder I'm just taking, let's take k as smaller and then p as bigger. Okay, not necessarily that they are bigger and smaller, no, but we're just taking them in this situation so that we can explain the concept that we want. Yeah. Is that okay? The one who asked the question?
All right, thank you.
All right. So you understand more when we do an example. Okay. So I'll go back to what I was saying there. All right. So since we've learned about the inequalities now, we've learned about the discriminant. Okay. Then we are ready to solve such questions that you are seeing there. Okay. So these questions are from your tutorial sheet one, which is on algebra. Okay. Alexis, you've raised your hand. You have a question?
Yes. I have a question. Can you get me?
Yes, you can ask.
Okay. What if one of the numbers was negative?
Okay, so if one of the numbers is negative, it means it will be the smaller number, right? If the other number is positive, the other one is negative, it means the negative one is the smaller one. Is that what you're
What if
asking?
both were negative?
If even if both they are negative, you have to have a bigger number and a smaller number. So for example, if I have -5 and -7, which one is bigger between these two?
-5.
Exactly. So any two numbers that you're going to get, okay, you have a situation where one is less than the other one, okay? Unless in a situation where we have the determinant being equal to 0, then they can't ask you such a question. There will be no need to ask you such a question. Okay, so any two numbers that you're going to get,
Okay.
one of them is going to be smaller than the other. Okay, so all right. So if that is clear, let's try to solve a question based on this concept here. So let's move together, okay? If you do not understand, please ask. So question 5a, they're saying find the range of values of k for which kx squared plus 8x plus 2k plus 7 equals to 0 has no real roots. Okay, so can someone tell us the interpretation when they say uh, the quadratic equation has no real roots? What do they mean? Anyone who can help. When they say that quadratic equation has no real roots, what do they mean? I'm just from explaining, guys. When they say the quadratic equation has no real roots, what do they mean?
It means that the discriminant is less than 0.
Exactly. So that's where you start solving your question from. Okay. So since this quadratic equation has no real roots, okay, then we know definitely that the discriminant has to be less than 0. Okay. So that's how we are going to find this range of values of k. So from this quadratic equation, let's write it here. Plus 8x plus 2k plus 7 is equals to 0. And then I'll write the general form just below this one. plus bx plus c is equals to 0. Okay, so from the quadratic equation that is above, okay, if I'm comparing it to this one in blue, then I can see that my a will just be k, okay? And then my b will be 8, and then my c will be whatever is remaining, which is 2k plus 7, right? Okay, so this simply means I have a is equals to k, b is equals to 8, and then c here we can expand. So this 2 multiplied by k, I get 2k plus 14. So this is my a, b, and c. Okay, and then from the formula of the discriminant, I know that my discriminant is b squared minus 4ac. But we know that this thing here should be less than 0 here. That's how we're going to find the range of values of k. Okay, so let's do that. So I'll erase this top part here. Okay, so we're going to say since it has no roots, then the discriminant b squared, okay, minus 4ac should be less than 0. And then let's replace now. So where there's b, I put 8 squared minus 4. A is k, c is 2k plus 14. This thing here should be less than 0. Okay, so you can see my inequalities even coming out. So this means that, okay, I have here 8 squared, which is just 64, minus, this will be 4 multiplied by k, that will be 4k, right? With the minus, of course, so it will be like minus 4k. Maybe I should just write it here to avoid confusing people. Less than 0. And then let's expand now the minus 4k with whatever is inside the brackets there. It was 4k. Then we multiply with this, becomes squared. So this one here, minus 4k multiplied by 14 should give us a 56k. This is what I was talking about. Okay, and then we can take these to the other side. So I have 0. So 8k squared. This one, it goes to the other side, becomes positive 56k. And then this one, since it's positive, it goes to the other side, becomes the minus 64. So that is what we have there. Okay, so now let's look at this one closely. So we have 8k squared, okay, plus 56k minus 64. And then this is greater. Where they are, it's greater here. So this will be greater than 0 like that. And then we see that all these things, all these numbers here, we can actually divide them by 8. So if I divide this by 8, divide this by, does 8 go into 56 anyway? Okay. Yeah, I think it does. Okay. So here you divide by 8, even here by 8, even there by 8. So here I'm going to get k squared, okay, plus 56 divided by 8, you're going to get 7k minus 64 divided by 8, I'm going to get 8 greater than 0. Okay, so now this is the quadratic inequality that we have. So remember the form, we said ax squared plus b x and then plus c greater than 0. How should be our answers? Okay, we said x should be less than the smaller one, or x should be greater than the bigger one. So let's try now to ignore this sign first of all, okay? And then just write this as k squared plus 7k minus 8 is equals to 0. And then let's solve this inequality. So this inequality now, or this equation is in terms of k. So I'm going to say product factor sum. Okay, so the product is 1 multiplied by minus 8, I get minus 8. The sum is positive 7. So what do you think the factors are going to be? Okay, what do you think the factors are going to be? So the factors are going to be 8 and minus 1. Exact. So when we add, we get this. When we multiply, we get that. So it means I have k squared, okay, and then minus k plus 8k minus 8 is equals to 0. Okay, we can group them, this k squared and k together, then this and this together. So what is common in the first bracket there? Okay, so what is common in the first bracket is k, and then I remain with k minus 1 What is common in the second bracket is 8, then I remain with k minus 1. And then this is equals to 0. Okay, so this simply means k minus 1, and then k plus 8 is actually equals to 0. So when you solve this, okay, when we solve that, what are we going to get? We're going to get, if I equate this to 0, I'm going to get that my k is equals to 1. Or if I equate this to 0, I'll get that k, x, why am I writing x? I'll get that k is actually equals to minus 8. Okay, so we can clearly see that this one is the smaller one. Okay, this one here is the what? Is the bigger one. So this is what I was saying. You always get two numbers and one of them will be bigger than the other. Okay, so once you find the answers now, you go back to the sign that you had. Okay, so since here we had a greater than, it means that our final answer should be k should be less than the smaller one, which is what? Minus 8. And then we say, oh, k should be greater than the bigger one, which is what? 1. So this one here should be your answer. Okay, you can even put it on the number line. Okay, it's going to be like this. So I have minus 8 there, and then here I have 1. So I'll put an open circle because I'm not including 8. Then I'll go to the left. And then here I also put an open circle, then I'll go to the right. So this part here is my solution set there. Okay, so any questions there? Are we good? Are we understanding?
Yes.
Okay, so let's look at
Yes, then.
the other one then. Okay, so let's look at the other one. So we are still applying the same concept. Okay, nothing different, just the same concept. So question C, they're saying the equation 7x squared plus 2kx plus k squared is equals to k plus 7, where this k is a constant, okay, has two real roots. Okay, the first one is show that k satisfies the inequality 6k squared minus 7k minus 49 is less than 0. Okay, so remember when we have a situation where we have two real roots, we said our discriminant should be greater than what? 0. So we're going to use this fact here to prove that k satisfies this equation here. So let's write the equation that we have down. So we have 7x squared, okay, plus 2kx, and then plus k squared. So now notice what I will do. I'm going to move this k and this plus 7 to the left hand side. Okay, so we are going to have minus k minus 7, and then this should be equals to what? To 0. And then from here we see that this is a standard representation of a quadratic equation. So we're going to get our a. Our a is always the coefficient of a squared. So it will be a is equals to 7. And then our b is always the coefficient of x. So it means our b will just be equals to 2k. And then our c is always whatever remains here and does not have an x. So the whole k squared minus k minus 7. Okay, this is our c. And then let's put this into the discriminant. So remember, we have two real roots here. So it means the discriminant is greater than 0. And we know that the discriminant is given by b squared minus 4ac. This is greater than 0. Okay, this is what we are going to use here. All right, so our b is 2k. We're going to say this squared minus 4, and then our a is 7, and then our c is just what? K squared minus 7 minus k minus 7. Okay, and we know that this discriminant here, because this question has two real roots, should be greater than what? 0. So let's show, okay, that we can manipulate this equation into becoming this equation here. Okay, so let's start. So we start with the first one there. So 2k squared is going to give me 4k squared, and then here I have minus 4 multiplied by 7 there. So that will give me a minus 28. So I have this minus 28 that I'm multiplying with whatever I have inside there. Okay, whatever I have inside there. So we are going to say minus 28 multiplied by k squared is going to give me minus 28 k squared minus 28 multiplied by minus k is going to give me plus, okay, 28k. Then minus 28 multiplied by minus 7 is going to give me plus 196, and then greater than 0. So this is what we have, right? So from there we can simplify it. Okay, so minus k squared and minus 28k squared, we can subtract those. So it's going to give me minus 24k squared plus 28k, and then plus 196 is greater than what? 0. All right, so from there we have to divide throughout. Okay, we have to divide throughout by minus 4. Okay, so let's do that. Okay, so minus 4 can go into all these numbers here. No wonder I've picked minus 4. So let's divide. So we have minus 24k squared divided by minus 4, then plus 28k divided by minus 4, plus 196 divided by minus 4 greater than what? 0 divided by minus 4. So because we are dividing by a negative number, it means that sign here has to change. Okay, from greater than it will change to less than. Right, so let's divide. So minus 24k squared divided by 4, I'm going to get 6k squared minus 28k divided by minus 4, I'm going to get minus 7k, and then 196 divided by minus 4, I'm going to get minus 49, like that. Okay, and then we said this sign here should change to less than 0. Why? Because we've divided by a negative number. All right, so now we've shown, okay, so this is part 1. This is part 1. So we've shown that k satisfies this equation. You can see this equation here. Okay, from whatever equation we had, we've simplified it to this equation here. So we can now go to the second part where they're saying find the range of possible values for k. So for us to find the range of possible values for k, we just have to solve this quadratic equation and then apply those rules that I said, okay, depending on the sign that you have here. So here we have a less than, so it means our answer should be in this form. Okay, where this b is the bigger number, then this a is a smaller number after you solve this quadratic equation here. Okay, so let's solve it. Okay, let's solve it. Okay, so we have 6k squared minus 7k minus 49. Okay, and then here we have a less than. So we are going to ignore that less than for some time. We're just going to say equals to 0. Okay, so can we find the product, the factor, and the sum for this equation? Okay, it turns out that we cannot. So if you cannot find, we just use the quadratic formula. So we are going to say a is equals to 6, okay, the coefficient of the variable that is squared, and then b is equals to minus 7, and then c is equals to what? Minus 49. So let's now use the quadratic formula. So the quadratic formula, you remember, it is given by x is equals to minus b plus or minus the square root of b squared minus 4ac, and then we divide by what? 2a. So in this case now we're not dealing with the variable x. So where there's x there, I'm going to put a k. Okay, because that quadratic equation is in form of k's. Okay, so k should be equals to this. So let's just substitute whatever we have now. So I'm going to say equals to minus, and then what is b? B is minus 7, and then plus or minus, we're going to have the square root of b squared. So b squared is minus 7, and then squared minus 4, and then a is given by what? Okay, let me write it here. It seems my space here is not enough. Let me write it down there. So we have minus 7 plus or minus the square root of minus 7 squared minus 4, and then what is a? A is 6, and then c is minus 49. Okay, and then I divide all this by 2 multiplied by a, which is 6. Alright, so what do I get from there? Okay, let's clean the above part. So from there, I'm going to have that my k is equals to minus 7 multiplied by 7, minus multiplied by minus 7. I'm going to get 7 plus or minus. Then under the root there, what do we have? Okay, we have minus 7 squared, which is just 49. And then here I have minus 4 multiplied by 6 multiplied by minus 49. Okay, so that's multiply that on your calculator. You'll be able to get 1176. And then divided by, here down we have 2 multiplied by 6. That will just be what? 12. So it means here this will be 7 plus or minus, and then under the root it will be 49 plus 1176, which will give me 1225. Then divided by what? 12. Alright, so what is the square root of so k is equals to, what is the square root of 1225? Okay, so the square root of 1225 is 35. And then we divide by 12. So it means we are going to have two answers now of k here. So the first answer will be 7 plus 35 divided by 12. Okay, so when I add this, it will be 42 divided by 12, which will give me 3.5. Okay, so this will be my first value for k. And then my second value, we say k is equals to 7, and then now we get the minus. Here we got the plus. So it will be 7 minus 35 divided by what? 12. So it means 7 will be equals to minus 28 divided by 12. So what is minus 28 divided by 12? I'm going to get 2. Okay, I'm going to get minus 2.3333 until forever. So we can round it off to 3 significant figures, so that would be 2.33. Okay, so we have our two values for k. Okay, we have our two values for k, so I'll just leave those two values for k, and then I'll erase the rest. Okay, so k can be 3.5 or k can be minus 2.33. Alright, so now you check the sign that you have there. Okay, so since we have a less than here, we're going to say our final answer will just be, we put k on the middle, and then we say it's less than the bigger number of this, which is 3.5, and then k should be greater than the smaller number of this, which is just minus 2.33. Okay, so whenever you have a less than, your answer should always be in this form. Okay, all right, so we found the range, the range of the possible values of this k. You can also put this in interval form. So in interval form, we are going to say this is just k should be a member of, okay, minus 2.33 and then comma 3.5. Okay, so meaning k is between these two numbers. All right, so that's it for this question. All right, now we go to question D. They're saying the equation k minus 4x squared minus 4x plus k minus 2 is equals to 0, where k is a constant, has no real roots. So if it has no real roots, we know that the discriminant is just less than 0. So the first question is show that k satisfies the inequality k squared minus 6k plus 4 is greater than what? 0. Okay, so let's write the quadratic equation that we've been given here. So we have k minus 4x squared minus 4x plus k minus 2 is equals to what? 0. So we know that from this quadratic equation we can get our value of a. Our value of a is always the coefficient of x squared, so that would be k minus 4. Our value of b is always the coefficient of x, which will just be minus 4. And then our value of c is everything that does not have x, so k minus 2. Okay, so we've been told that this quadratic equation does not have real roots, so the discriminant is less than 0. We know the discriminant is given by b squared minus 4ac. So this discriminant here should be less than 0. Alright, so let's write it in terms of the numbers that we can see here. So we're going to say b squared minus 4 and then A is k minus 4, and then multiplied by C, which is k minus 2. Okay, this should be less than 0. So this is what we have. Okay, so from there we need to expand. So minus 4 squared, you give me 16, and then here I'm going to have minus 4, and then I multiply what I have inside there. So k minus 4 and then multiplied by k minus 2. So k multiplied by k, I'm going to have k squared. K multiplied by minus 2, I'm going to have minus 2k. And then minus 4 multiplied by k, I'm going to have minus 4k. And then minus 4 multiplied by minus 2, I'm going to have plus 8. Okay, and then all this should be less than 0. So we continue manipulating this equation. Okay, so from there we are going to have that 16. Okay, and then here now we can multiply this 4, minus 4, we can multiply it with whatever we have inside here. So inside here we have minus 2k minus 4k, so that will be minus 6k. Okay, so it will be minus 4 multiplied by minus k squared, it will be minus 4k squared, and then minus 4 multiplied by minus 6k. When we add this minus 2 and minus 4, okay, we're going to get positive 24k, and then minus 4 multiplied by 8, I'm going to have minus 32, and then all this is less than 0. Alright, so from here we have to put the like terms together. We put the like terms together, so we see that minus 4k squared, and then we can put plus 24k, and then this 16 and this minus 32, we can add them, so they are going to give us minus 16, and then this should be less than what? 0. And then from here we're going to divide throughout by minus 4, even this side by minus 4. Right, so when we divide by minus 4, we're going to get k squared. Okay, and then 24k divided by minus 4, we're going to get minus 6k, and then minus 4 divided by minus 16, I'm going to get plus 4. And then since I divided with a negative number, it means this sign here has to change the sign, so it will be greater than what? 0. So you can see that what we have now is what we've been told to show. Okay, so that k squared minus 6k plus 4 is greater than 0 is what we have here. Okay, so we can write hence shown. So we have shown that, and then we go to the second part where they're saying find the exact range of values of k. Okay, so that one is very simple. Okay, so if you don't know the basics of the question that I'm solving here, just search how to find the range of values given a quadratic equation, and then in front put tutor solutions. You'll be able to find the video where I was explaining all the basics here. Alright, so we have this inequality here, 6k and then plus 4, which we just showed. So we want to find the range of possible values for this k here. So the way we do this is that we first solve this quadratic equation normally, and then once we solve, okay, we are going to get k is equals to a certain number, let's say a, and then we're also going to get k is equals to another number, let's say b. Okay, so as long as you have a greater than here, or greater than or equal to, your answer should always be in this form. We're going to say k is greater than the bigger number of the two answers that you get. Okay, so let's say the bigger number was b, so it will be k is greater than b, and then you say or k is less than the smaller number of the two that you're going to get. So let's assume it was the a. Okay, so your answer should always be in this form as long as you have a greater than or greater than or equal to. So let's solve this quadratic equation here the normal way we would solve a quadratic equation. So we're going to say k squared minus 6k plus 4 is equals to what? 0. So let's find the product, the factor, and then the sum. So is it possible to find the product, the factor, and the sum? So the product is 4, okay, and then the sum is minus 6. So can we find the products here? I mean the factors here. Okay, it turns out this question does not have any factors, so we can use the quadratic formula. So that quadratic formula is now in terms of what? K. So we're going to say K is equals to minus B plus or minus the square root of B squared minus 4AC, and then we're going to divide all this by 2A. Okay, so this is going to be equals to minus B. So minus, so our B from this inequality here, okay, our B is the coefficient of K. Okay, let's say A will just be the coefficient of K squared, which is 1. B will be the coefficient of K, which is minus 6. And then C will be the value with no X, so meaning 4 there. Okay, so it means our B is minus 6, and then plus or minus the square root of, so B squared, it will be minus 6 squared, then minus 4. A will be 1, and then C will be 4. And then we're dividing all this by 2 multiplied by A. A is 1. Okay, so that's the quadratic equation that we have there. So let's continue solving. So it means from there I'm going to have K is equals to minus multiplied by minus 6, that would be positive 6, plus or minus, and then inside the root there we're going to have minus 6 squared, that would be 36, and then minus 4 multiplied by 1 multiplied by 4, that would be a minus 16, and then I'm dividing all this by 2. So this will be equals to 6 plus or minus the square root of here 36 minus 16 is going to give me a 20. Okay, it's going to give me a 20 there. And then I'm dividing all this by 2. So I can get my two answers of K now from this. Okay, I can get my two answers of K from this. So my first answer of K will just be equals to 6 plus the root of 20. So this root of 20 here, okay, we can that root of 20 we can simplify it, okay, because this is a rad here. So root of 20 is the same as root of 4 multiplied by 5. Then we distribute the root, that will be root of 4 multiplied by root of 5, and we know that root of 4 is 2, and then multiplied by root of 5. Okay, so this root of 20 here is the same as 2 multiplied by root of 5. Okay, so I'm going to use that, but if you want, just leave it as the root of 20, there is no problem. Okay, so I'm going to use 2 and then root of 5, and then this we are dividing it by what? 2. So this will be our first answer, and then our second answer we're going to say OK is equals to 6 minus 2 root of 5, then divided by what? 2. Alright, so from there what do I get? Okay, as my two values of K. So the first one will be K is equals to 2 divided by whatever I can see here. Okay, so 2 will divide the 6, and then it will divide the 2 multiplied by root of 5. So that will be 3 plus root of 5. This will be my first value of K, and then I'm going to say, or my other value of K will be 2 divided into 6 to be 3, 2 divided into minus 2 root of 5, it will be minus root of 5. Alright, so those are the two answers that we have. So remember the trick that we are now going to use since we have an inequality there. Okay, so the inequality that we have is a greater than, so our answer should be in this form. So we're just going to say K is greater than, which number is greater between this one and this one? We see that this one with a plus root of 5 is greater, so we're going to say K is greater than 3 plus root of 5, and then or K is less than the smaller number, which is what? 3 minus root of 5. Okay, so this here is our answer. So we can also put this in an interval form. Okay, we're going to start with that one which is less than this number. So we're going to say K should be a member of the following interval. So from minus infinity, okay, from minus infinity here all the way to 3 minus root of 5, and then comma, starting from 3 plus root of 5 all the way to what? To positive infinity. Positive infinity, like that. Okay, so you can represent your answers in two ways. Okay, you can represent it in this form, or you can represent it in that form. There is no problem. Alright, so let's look at the other question here. Okay, so the other question here, they're saying a straight line with the equation y is equals to 3x minus 7 does not cross or touch the curve with the equation y is equals to 2px squared minus 6px plus 4p, where p is a constant. Okay, so now here we're dealing with p and not k. Right, so the first question here, they're saying show that 4p squared minus 20p plus 9 is less than 0. So how are we going to show this? Okay, so remember what we've been given there. We've been given that y is equals to 3x minus 7. This is what we've been given. And then we've also been given another equation of the curve, which is 2p x squared minus 6px and then plus what? 4p. Alright, so for us to show that this equation is true, we just have to substitute this equation of this curve here. Okay, we substitute it into this equation of the curve. So now notice what we've been told. We've been told that this line with the equation 3x minus 7 does not cross or touch this curve here. So what does that mean? It means when I substitute this equation of a straight line into this curve here, okay, the quadratic equation that I'm going to have, okay, or the final results that I'm going to have will not have a solution. And we know that a quadratic equation, if it does not have a solution, then the discriminant is less than what? 0. Okay, so let's substitute. So we are going to say the equation of the curve is y is equals to 2p x squared minus 6px and then plus 4p. Okay, and then we've also been given that y is equals to minus 3x minus 7 there. So what are we going to do? We are going to substitute this y here with the 3x minus 7. So we're going to say 3x minus 7 is equals to, and then on the other part we're going to have 2p x squared minus 6px and then plus what? 4p. So this is what we have. So let's put the like terms together. Okay, so this is going to be equals to, I'll move all these guys to the right hand side. So this will be 0 is equals to 2p x squared minus 6px, and then this 3x here, when I take it to the other side, it's going to be minus 3x, and then I have plus 4p, and then this minus 7 here, when I take it to the right hand side, it's going to be a plus 7. Okay, so this is the quadratic equation that we now have. So let's write it in the standard form. Okay, let's write it in the standard form. So in the standard form, this equation is going to be 2p x squared. Okay, and then here I can notice that I have x here and then x here. So I can factorize the x. Okay, I can factorize the x. So I'm going to say plus, and then when I factorize the x, it means here I'm going to remain with minus 6p, here I'm going to remain with minus 3. So I'm going to write minus 6p, then minus 3, and then the x, I'll write it outside like that. Okay, and then I'm going to write whatever remains there, which is 4p plus 7. Okay, so remember this guy here was equals to 0. So we can write the equals to 0 this side now. Okay, amazing. So from there now, we can get our value of a, our value of b, and our value of c. Okay, and then place them in the formula for the discriminant. So our a will just be 2p. Okay, the coefficient of x squared. Our b will just be minus p minus 3. And then our c will just be whatever does not have x, which is 4p plus 7. Alright, so we are told that this line here does not touch this curve here. Okay, and when we substituted it, we found this quadratic equation. So if that line does not touch that curve, it means this quadratic equation that we have here, okay, has no solution or no real roots. Okay, so if it has no real roots, it means the discriminant is less than 0. And then we know that the discriminant is given by b squared minus 4ac. Okay, so I'm going to write now the discriminant in terms of these values here. So the b is minus 6p minus 3. So I'm going to say this squared and then minus 4. What is our a? Our a is 2p. And then multiplied by c, which is 4p plus 7. Okay, and we know that this discriminant here, since this equation has no roots should be less than what? 0. So this is the equation that we now have. Okay, so from here, what are we going to do? We are going to try and simplify this equation that we now have. Okay, so let's start with this one. So here we are multiplying 6p minus 3 with 6p minus 3. So we are going to start with minus 6p, okay, multiplied by minus 6p. I'm going to have 36p squared. And then minus 6p multiplied by minus 3, I'm going to have plus 18p. And then we start now multiplying this minus 3. This minus 3 multiplied by minus 6p, I'm going to get plus 18p. And then minus 3 multiplied by itself, I'm going to get plus 9. Okay, and then we go here. Okay, so this here will be minus 4 multiplied by 2p, which will just be minus 8p. So we are multiplying minus 8p with what we have in the brackets there. Okay, so let's multiply. So we are going to say minus 8p multiplied by 4p squared. What are we going to get there? Okay, we're going to get minus 32p squared, and then minus 8p multiplied by 7. We're going to get minus 56p, and we know that this here is less than what? 0. So now let's simplify whatever we have there. Okay, so we are going to say we group the p's, the p squareds together, so it will be 36p squared minus 32p squared, and then we group the p's together, so it will be minus plus 18p plus 18p, then minus 56p. Okay, and then we can group whatever does not have a p together, so we only have a 9, so we're going to say plus 9 is less than what? 0. So 36p squared minus 32p squared is going to give me 4p squared, and then 18 plus 18p is going to give me 36p, and then 36p minus 56p is going to give me minus 20p, and then plus 9, this is less than what? 0. So we have answered the first part there. We have shown, okay, that 4p squared minus 20p plus 9 is less than what? 0. Okay, so that's how we show. And then now we go to the second part, which says hence find the set of possible values for p. So to find the range, okay, of the possible values for p, we just need to solve this quadratic inequality that we've found there. Okay, so the quadratic inequality is 4p squared minus 20p plus 9 is less than 0. So how do we solve a quadratic inequality? Okay, we just solve this quadratic part, okay, in the same way we would solve a quadratic equation. And then once you get those two answers, you check the type of sign that you have there. So if you have a less than there, it means your final answer will just be like this. Okay, you put b there and then a, where this a will be the smaller number of the two numbers we're going to get from this quadratic equation, and then this b will be the bigger number from the two numbers that we're going to get in this quadratic equation. All right, so let's try to solve this. All right, so are there any factors, okay, for this question here? Okay, we see we have no factors, so just use the quadratic formula. So we're going to say p is equals to minus b plus or minus the square root of b squared minus 4ac, and then we're dividing this by 2a. So this is going to be equals to minus, okay, so let's get our b, our a, our c. So our a here will just be 4. So the coefficient of p squared, or whatever variable you have here, it can be z, it can be k, it can be any variable. And then b is equals to minus 20, then c is equals to what? 9. So here we're going to say minus, and then b is minus 20 plus or minus square root of b squared, so minus 20 squared, and then minus 4. What is the value of a? The value of a is 4. The value of c is 9. Okay, and then we are dividing all this by 2 multiplied by a. So this is going to give us is equals to, okay, so the first one minus multiplied by minus 20, that will be positive 20 plus, and then under the root, what are we going to have? What is 20 squared? 20 squared is 400, and then 4 multiplied by 4, I'm going to get 16. 16 multiplied by 9, I'm going to get minus 144. Then this here we divide by 2 multiplied by 4, which is just 8. Okay, so these are the values of p. So p is going to be equals to 20 plus or minus. What is 400 minus 144? 400 minus 144, it's 256. And then we're dividing this by 8. All right, so we can erase this part. So it means we are going to have that p is equals to 20 plus or minus. The square root of 256 is 16. And then we're dividing this by what? 8. So it means p will be equals to 20 plus 16 and then divided by 8. This will be our first answer. Or p is equals to 20 minus 16 divided by 4. So this is going to be equals to what? Okay, so 20 plus 16 is going to give me 36, and then 36 divided by 8 is going to give me 4.5. Okay, and then or p is equals to 20 minus 16 is going to give me 0.5. Okay, it's going to give me 0.5. No, I mean 20 minus 16 is going to give me 4, and then 4 divided by 8 is going to give me 0.5. Okay, so we have our two values for p. Okay, once you get the two values for p, and then you can go back to the original equation. So the original equation had less than here, so it means our final answer should be in this form, where this b is the bigger number of the two answers that we found here. Okay, so it means p would be between, which one is smaller between the 4.5 and 0.5? So 0.5 is smaller, and then 4.5 is bigger. Okay, so this here will be our answer. We can also put it in interval notation. Okay, in interval notation, just be p is a member of 0.5, comma 4.5. Okay, and then that's all for this question here. Okay, so please like, share, and subscribe to my channel for more videos. Okay, for those who want to register for our online classes, okay, you can inbox me on the number in the description below. Thank you so much for watching. So those questions, we actually got them from tutorial sheet 1 for those who are at uni that's doing pre-meds. Okay, so if you would like to access the full videos to all the questions from tutorial sheet 1, starting with this one on the sets of numbers, and then we went to tutorial sheet 2 where we're looking at exponents or indices, to SADs. Okay, these are rationalizing the denominator. We have video solutions explaining all these questions here. Okay, so if you'd like to access those videos, you can actually access them on our website. Okay, all these questions, we solved them all the way up to question 7. Okay, so if you'd like to access the full videos, feel free to go on our website, and then you can find them there. Okay, so let me just show you our website. So when you go on Google, okay, so just type discretelearning.com, and then you click search. Okay, so our website is going to come up. So this is our homepage, like that one, and then you can check out what we have there, the courses for pre-med, biology, physics, chemistry. There's also mathematics. Okay, so you can click on subscribe course. So if you have an account, it will take you to the login page here. So you put your email there, and then here you put your password. Okay, if you do not have an account, you go down here where there's create an account. So you create an account for yourself. Okay, and then once you're done, you use those details to log in. Okay, so when you log in into the platform, this is what you're expected to see. Okay, so you can go down here onto the courses. Okay, so for you guys, it will be showing not enrolled there, not enrolled here. Okay, until you enroll for that course. Okay, so once you enroll for that course, there are just simple steps that you follow. Okay, you can watch the registration guide in the comments below. There's a video that I did showing you how to register. So once you are done registering, okay, you can click view course. Okay, and then it's going to open like this. So we have general mathematics and then probability and statistics. This is specifically for those who are doing second semester at Apex, this folder here. Okay, but for you guys, you go in general mathematics. Okay, so what you're going to find here is 4 folders. One is for the lessons and the tutorials that we do. Okay, so each class that we have here at Discrete Learning Institute, we record it. Okay, so there's no missing class. So we also have the folder for tutorial sheets here. So here, that's where you're going to find the full videos for all the tutorial sheets. Okay, so there are different universities here depending on where you are. Okay, so if you are At Unilas, for example, you'll find the folder for Unilas. Okay. If you're at any other university that is not listed here, you open this course here, this folder, I mean, where we wrote our tutorial sheet and explain solutions. Okay. If you are from any other university that you can't see here. So if you're from Unilas, just click Unilas. Then you find semester 1 and semester 2. If you're from semester 1, you go in semester 1. Okay. And then in semester 1, you're going to find the lecture notes for Unilas, semester 1 topics, written solutions to the tutorial sheets, as well as videos. So you can go in videos. Okay, that's what you want. And then there's the January intake and the July intake. Okay, so July intake, so far you only have one tutorial sheet. So that's what we've solved. Okay, so you can see tutorial sheet 1, question 1, 2, 3, 4, 5, 6. So these are the full videos for all the questions in that tutorial sheet 1. Okay, so you can access them here. And then if you have an Android phone, okay, once you register on the website, please inbox us your email so that we send you the app. So the mobile app, you can download these videos when you're at school using Wi-Fi. You download the videos, and then when you go back to your boarding house or to your room, you can watch them offline on the mobile app. Okay. Okay, so those are the videos for tutorial sheet 1. And then if you like learn on your own, you can go in the January intake. You'll find videos on all the tutorial sheets. Okay, so from tutorial sheet 1, which is algebra, the next tutorial sheet will be on functions. Okay, so that tutorial sheet, I'm very sure they're not going to change a lot of questions. So you can open this tutorial sheet 2 here. Tutorial sheet 2 is on functions. Okay, you're going to find the videos on what? On functions. So we solved all the questions again for that topic, functions. Okay, so it's the same with all these other tutorial sheets. You can open tutorial sheet 5. You're going to find the videos there. Okay, but they are ready and waiting for you to learn. Okay, so this is actually a very good platform. You can learn at your own time, in your own space, okay, at your own pace. All right, so I hope you enjoy this website, okay, as you'll be learning these concepts. Okay, so if you have any challenges, feel free to actually inbox me. Okay, and when you register on the website, okay, you have a part, this one here, where it's written WhatsApp groups. Okay, so depending on the university you are from, there's a WhatsApp group that you should join, okay, for the registered students at that university. Okay, so make sure that when you register here, you also join the registered WhatsApp group so that you don't miss the updates that we make. Okay, so thank you so much for watching, and continue studying.